Hello, this is Jack Jackson. We're going to be talking about exact values of trigonometric functions of certain special angles today. So first of all, let me remind you of the general definitions of the trigonometric functions right here. And remember what we do. We place an angle in standard position and let its measure be theta, any theta. And so So we can take an angle and rotate it around, and what you see here is the reference triangle. And of course we take a point any length out of 1, and the arc that it traces through, this arc on the unit circle, is the measure of that angle. Okay, and of course we measure, go clockwise, it's positive, the other direction it's negative. But the point is, we spin it however many times it spins, and then it lands somewhere. And then we have the coordinates of some point here, B. Its coordinates are x, y, which there they are, x and y. And there they are at the moment. And we define that to be, actually it doesn't have to be on it doesn't have to be on the unit circle, it can be on any distant out. Just take any point on that terminal ray, find its x and y coordinates, then find r, its distance to the origin, which is the square root of x squared plus y squared, and now we have an x and a y and an r coordinate associated with some point on that terminal ray. Then we just use these general formulas to define the trig ratios. Cosine of theta is x over r, sine of theta is y over r, and tangent of theta is y over x. Secant of theta is r over x, cosecant of theta is r over y, and cotangent is x over y. Notice that when they're both defined, secant and cosecant, cosine and secant are reciprocals of each other. When they're both defined, sine and cosecant are reciprocals, and when they're both defined, tangent and cotangent are reciprocals of each other. Okay, so I'm going to hide that variable angle. I'm going to hide these definitions. Now, as you can read here in the introduction, what we're going to do is examine the exact values of the trigonometric functions at several special angles. We're going to start by considering the axial angles, that is, those angles with a terminal side pointing along one of the coordinate axes. So that'll be angles that are multiples of pi over 2 for their measurement in radians, multiples of 90 degrees in degrees. Okay. And we'll then proceed to angles that are formed by placing one of our special triangles centered at the origin. And so they'll have reference angles of pi over 4, 45 degrees, pi over 6, 30 degrees, or pi over 3, 60 degrees. And of course all of our angles are going to be in standard position. So as the instructions tell us to do, we're going to click here to hide the instruction. So this particular video we're going to focus on the axial angles, and then we'll probably have a series of three or four of these little videos. So the axial angles are the ones that are pointing along one of these sides here. So if you look on where the unit circle here meets the axes, those are the points 1, 0, 0, 1, negative 1, 0, and 0, 1. Now, so what angles are these? Well, if you don't spin the, let me put a ray here I can spin. So if we're here and we don't go at all, that's an angle of 0. But we can also spin a ray 2 pi radians, or 360 degrees, and if we land right back up on the axis, we're going to end up at the same place we started. Or you could spin this way, negative 2 pi. Or you could spin like this, 2, 4 pi, negative 4 pi. Or positive 2 pi, 1 pi, 2 pi. Positive 6 pi, 1, 2, 3, 4, 5, 6 pi. all of those angles, any multiple of 2 pi, leaves us back right at on top of the initial ray, pointing along the positive part of the x-axis. All of those points have an x of 1, a y of 0, and an r of 1. Similarly, we can spin to here. The shortest way to go would be just spin like this, would be 90 degrees or pi over 2 radians. So notice this is pi all the way here straight, half of that would be pi over 2. So spinning like this is an angle of pi. Of course, we could spin the other direction, an angle of negative 1, 2, 3 pi over 2, negative 3 pi over 2, or we could go more than once around. So pi over 2 plus another 2 pi, which would take us around to here. So let's do that again. So it's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2 would put us right there. Okay, any of things that end here, it really doesn't matter how many times we spin this thing around, as long as we end up here, that's what's going to matter when we look at these definitions over here of our trig functions. We just need an x and a y and an r. And where we are right now, x is 0, y is 1, and r is 1. And then we just plug those numbers in here, and we will get the trig functions defined. Okay. Similarly, if we go over here, this is one angle here is pi. Another angle that will give us there is this way, negative pi, or maybe 3 pi. 1, 2, 3 pi. In fact, any odd multiple of pi will give us right here. Okay, and that'll go through the point negative 1, 0, and r is 1. Down here, if we spin this way, it's pi over 2, 2 pi over 2, 3 pi over 2, right there. So that's 3 pi over 2. Or if we spin this way, it's negative pi over 2. And of course, there are many other ways we can spin. As long as we end up right there, pointing straight down on the negative part of the y-axis, we get x is 0, y is negative 1, and r is 1. So the main point is it doesn't matter how many times we spin around, then we end up at the same place. Then we get the same values of the trig function. So let's take a look at these 4 different ones. Look right here first. If we don't spin at all, or we spin a multiple of 2 pi, so that we end up going right back where we started, the terminal ray and the initial ray on top of each other, what would be some angles there? Well, one of them would be 0 radians, or 0 degrees, and of course we could add any multiple of 2 pi radians to that, so it would be 0 plus 2n pi, or just 2n pi, where n is an integer, or 0 degrees plus n times 360 degrees. And we see that in all those cases, one point that we could get on the terminal way has x1, y0, and r1, and from that we can do our trig functions. So the cosine of 0 is x over r, so it's 1 over 1 is 1. Sine of 0 is y over r, so 0 over 1, which is 0. Tangent of 0 is y over x, 0 over 1 is 0. Secant of 0 is r over x, 1 over 1 is 1. Now cosecant and cotangent are respectively r over y and x over y. In both cases, since y is 0, those are undefined. So cosecant and cotangent are undefined. You're going to see on these axial angles, 2 of the 6 functions are always going to be undefined, and the other 4 will be either 1, negative 1, or 0. And you're also going to see that the sine and cosine are always defined. So they're either 1, negative 1, or 0. Okay, so now let's look at this one here. So that's the one that's pointing along the positive part of the x-axis. So if we spin up here and we stop pointing straight up on the positive part of the y-axis, that would be an angle of pi over 2, or 90 degrees, the way I spin it there. If we spin the other way, that's negative 3 pi over 2, or negative 270. Or, of course, we can have any multiple of 2 pi plus the pi over 2. So, anyway, we go through the point 0, 1, and r is 1. So x is 0, y is 1, r is 1, and use our definitions. So cosine of pi over 2 is x over r, so that's 0 over 1 is 0. Sine is y over r, or just y, since r is 1, which is 1. Tangent's going to be undefined because that's y over x, so it's 1 over 0. Cotangent, however, is defined. It's x over y, 0 over 1 is 0. So notice that when the things that we normally think of as reciprocals of each other, tangent and cotangent, when one is defined, the other one, when one is undefined, the other one is 0, and when, and vice versa. And then if they're both defined, then they're reciprocals of each other. Okay? So when cosine is 0, secant is going to be undefined. And of course, if sine being 1, cosecant, its reciprocal is also 1. And again, just use those basic definitions that we had up earlier. Now what if we start here at the initial ray, spin it, and we go all the way a half circle, or at least we end up at the negative part of the x-axis, pointing directly opposite from what we started with. Well, one possibility of that is a straight angle measuring pi, or 180 degrees. Of course, we could have also started here and spun it in the negative direction. Okay, and that will get us to negative pi, or negative 180 degrees. And there, of course, there are infinitely many others that will get us to the same place. But they all have the same terminal side, and they all go through that point negative 1, 0, which would have a radius of 1 for the unit circle, a distance to the origin of 1. So we get x is negative 1, y is 0, r is 1, and just go with our definitions for the trig functions. Cosine of pi is x over r, it's negative 1 over 1 is negative 1. Sine is y over r, 0 over 1 is 0. Tangent is y over x, that's 0 over 1 is negative 1 is 0. Secant is 1 over cosine if it's defined, so it is, it's negative 1, or more generally it's r over x, so it's negative 1. Cosecant and cotangent are undefined because we would be dividing by 0. The y is 0, and let's see, cosecant is r over y, cotangent is x over y. In both cases, y is in the bottom and y is 0. That's not going to work when y is 0, so it's undefined. Finally, let's look at the last axial angle. We can think of rotating a positive way as pi over 2, 2 pi over 2. That would be 3 pi over 2. Or the shortest way to rotate would be in the negative direction, negative pi over 2. Okay, so if we think of this as 3 pi over 2, or 270 degrees, or negative pi over 2, or negative 90 degrees, either way we're going to get an x and y of 0, negative 1, and r of 1. And so cosine is x over r, that 0, 1 is 0. Sine is y over r, so it's negative 1 over 1 is negative 1. Tangent is y over x, but x is 0, so tangent's undefined. Notice when tangent's undefined, cosine is 0. Cotangent is 0. Tangent's undefined, cotangent's 0, and cosine is 0. Both of those are true. So tangent's undefined when the x is 0, x is the cosine, and then the cotangent will be 0 in that case. So when cosine is 0, secant's going to be undefined because that's r over x is 1 over 0, which is undefined. We cannot divide by 0. When sine is negative 1, cosecant is going to be the same. So notice when sine or cosine are 1, its reciprocal function, cosine and secant, are both 1. Sine and cosecant are both 1 over here for the one up here in this quadrant. That's not on a quadrant. It's pointing straight up. When we go straight to the left, which one do we have? We have cosine and secant are both negative 1. And down here, straight down, we have cosecant and sine are both negative 1. Notice whenever we have one of the things is 0, its reciprocal is undefined. So when sine is 0, cosecant's undefined, and that makes cotangent undefined as well. Okay, so sine and tangent are 0 here. When it's pointing straight to the right or straight to the left, y is 0. So if it's on the x-axis either direction, then notice that sine and tangent are both 0, and the cosecant and cotangent are undefined. on the other hand, if it's pointing straight up or straight down, in other words, on the y-axis for the terminal side, either direction, then we notice the x is 0, which is going to make cosine 0, okay, and that's going to make the secant undefined and the tangent undefined, but the cotangent 0. And that's going to be true down here too. If it's pointing straight down, same thing. Cosine is 0 because x is 0, which makes secant undefined and tangent undefined, and the cotangent 0. So those are your trig functions for your axial angles. Some textbooks will call these quadrantal angles. I don't particularly like that term because actually if the angle is not on an axis, then it's in one of the quadrants. This is quadrant 1 for the terminal side, quadrant 2, quadrant 3, quadrant 4. But if it's on an axis, it's actually not in a quadrant. So I think a probably more proper term would be non-quadrantal angle, but the books call those quadrantal angles. At least one of the books does that we use sometimes. But I call them axial angles because I think that's a better term because the terminal side is on an axis. Okay, let's, I think we'll stop there for this one. But basically, well, one more final thing. Just remember, if you're wanting to figure these out, rather than trying to memorize all this stuff, what do you need to really know? Okay, you need to memorize the definitions of the trig functions. That you have to memorize. But then all you have to remember here is just draw out a unit circle. You can just sketch it out, and remember it's going to go through 1, 0, 0, 1, negative 1, 0, and 0, negative 1. That's pretty easy. And all these have radius 1. And once you have an x, y, and an r coordinate, then these definitions that you have right here will easily give you all the trig functions. So quadrantal angles, or axial angles, which I think is a better term, pretty easy to find the trig functions of those.